Okay, in this video, let's look at problem 6. The circuit is shown on the screen. Okay, um, now we can use the ideal diode model in this circuit. And what we can do is we can say, okay, let's say this voltage is positive. Okay, this is a changing voltage. And let's say we are in a positive half cycle of your sine wave. Okay, when the voltage is positive, in which direction would the current flow? The current would flow in this direction, right? And if the current flows like this and it flows here, now you can see, okay, how can the current go? Can the current go through this diode? No, it cannot, right? It cannot go through this diode. So the current will try to go through this diode. Okay, and it's possible to go if D2 is forward biased, right? If D2 is forward biased. And then the current, can it go like this? Can it go through D3? No, it cannot. So the current will have to follow this path, right, through the resistance, and it goes like this, and now here again you can ask the question, okay, in which direction can the current go? Will the current go like this through D4 or will it go through D1? Now remember what we assumed when we came here. The current was going through D2 and not through D1, and we assumed that D1 is in reverse bias, right? So let's leave D1 in reverse bias, so the current has to go through D4. So if it goes to D4, then it goes through here. Again, D3 is in reverse bias and it goes back to the supply. Okay. So this will happen if, as we assumed, D2 and D3 are forward biased, right? And if D1 and D4 are reverse biased. Now, when is that going to happen? When is D2 and D4 are forward biased, right? And D1 and D3 are reverse biased. Sorry about that. Okay, so the question is, okay, when are D2 and D4 forward biased? Well, D2 and D4 are forward biased when this voltage is more positive than this voltage, and when this voltage is more positive than this voltage. And when is that going to happen? Right? That is going to happen when this voltage is more positive on this side, because if this is positive, this will be positive, and this D2 is going to be forward biased. And if this voltage is the negative half, then this will be the negative voltage, and therefore D4 will be positive, right? So you can see kind of from analysis that uh, like in a very qualitative sense, that D2 and D4 are going to be forward biased in the positive half cycle. Okay. Okay, now let's look at what happens in the negative half cycle. And I'm going to write with red here to distinguish from what we did. So we have negative here and we have positive here, right? And so in which direction is the current going to flow? The current is going to flow in this direction, right? And then it goes like this, it goes like this. Now you may ask the question, okay, which path is it going to take, D4 or D3? Now take a look at your voltage. It is positive in which direction? It's positive here. So you have a positive voltage here and a positive voltage here. Okay, positive voltage on the N side of D4 and a positive voltage on the P side of D3. So which is going to be forward biased? Of course, it's going to be D3, isn't it? And then again, this side is negative. This side of the power supply is negative. So look at D1 and D2. The P side of D2 is negative and the N side of D1 is negative. So which one is going to be forward biased? Of course, it's going to be D1, isn't it? Right? So in this case, D3 and D1 are forward biased and D2 and D4 are reverse biased. Now, if D2 is forward biased, the current again flows in the same direction through the resistor, right? It goes like this, goes up here, and then through D1, it goes back into the power supply, right? So you can see that in both the positive and the negative half cycle, the current flows in the same direction through the resistance, right? So current times R is going to give you V naught, And so what you can say is, if you have a sine input like this, let's say, okay, you have to imagine that this is a sine wave in spite of my drawing. Okay, now let's try to draw the output here. So in the positive half cycle, the current flows through the resistor in the positive direction, right? So you have something like this. So in the positive, okay, now in the negative half cycle, what happens? The current still flows through the resistance in the positive direction, and therefore even in the negative half cycle you'll have things like this. So that's going to be your output, right? And this is basically a rectifier circuit, but this is called a full wave rectifier. In the class we did a rectifier called half wave rectifier because it cut off the negative half cycle. But a full wave rectifier, what it does is it uh, it's basically taking the absolute value of the sine wave, isn't it? It shifts the negative half cycle or mirrors it onto the positive side of the axis. Hopefully that makes sense.